The problem statement states that Mihai and Bianca are playing with bags of candies. They have a row A of n bags of candies. The ith bag has 8 ith candies. The bags are given to the players in the order from the first bag to the nth bag. If a bag has an even number of candies, Mihai grabs the bag. Otherwise, Bianca grabs the bag. Once a bag is grabbed, the number of candies in it gets added to the total number of candies of the player that took it. Mihai wants to show off, so he wants to reorder the array so that at any moment, except at the start when they both have no candies, Mihai will have strictly more candies than Bianca. Help Mihai find out if such an ordering exists. So we are given 3 inputs: T, which is number of test cases, N, the number of bags in the array, and N, space separated integers, A, I, the number of candies in each bag. And for the output, we output yes if such a reordering exists and no otherwise. So if we take a look here at the example, we have, for the first test case, we have 1, 2, 3, 4, and it outputs yes, because we can order it like this: 4, 4, 1, 2, 3. So when Mihai places down the 4, Bianca has 0. Now Bianca places the 1, Mihai has 4, so he still has the greater amount of candy. Then Mihai puts down 2. Then that means Mihai has 6, and Bianca still has 1. So we're still keeping that strictly greater than Bianca rule alive. Now, when Bianca places down one bag, 1 candy, then that's also strictly greater because Mihai has 6 and Bianca will only have 4. And for this test case, we have 1, 1, 1, 2, and it prints no, because we can, by simple logic, we can see that Bianca has more candies than Mihai at the end. So therefore, no matter what, Mihai wouldn't get an reordering that in which he will have more candies than Bianca. So let's just try one for example. We can do 1, 2. Okay, Mihai has the greater than Bianca so far, but then she places down another one, so it's 1, 2, 1, and that wouldn't happen anymore, right? And then now for the last case, we can see that no matter what we place, Mihai has 4, and Bianca has 1 and 3. So if we look at the current ordering right now, 1 and then 4, or for example, since Mihai has to be strictly increasing, we can do 4, 1, 3. Okay, so let's see. 4, when Mihai places down 4, Bianca has 0. Then she places down 1. She has 1, and Mihai is still greater than Bianca right now. But then Bianca has another 3. So if she places down 3, they have equal. So therefore, that's already a no. So from these 3 examples, we can deduce some rules, right? Mihai should always place his candies first, and we also have to check that number of candies that Mihai has at the end should always be greater than the number of candies that Bianca has. And this will be like a greedy algorithm, which builds a solution by making a sequence of optimal choices, hoping that they lead to a globally optimal solution. So in our case, what we're saying is our greedy solution is that we will have Mihai always place his even size bag as early as possible. But the root of the problem is that we just have to ensure that Mihai has a greater number of candies compared to Bianca. So for this code, we have we get the input, which is the test case, like we said earlier, and we get the n and the candies array. Now we can set two accumulator variables, e and o. E for evens, o for the odds, and then we iterate through for um, each number in candies. If it's even, we accumulate it to the e variable. Else, we accumulate it to the odd variable. And then this is just a simple check at the end. If e is greater than 0, if e is greater than o, then we print yes, because at any given point, especially if we use the greedy solution in mind where we have Mihai always placed first, then let's say we have 4, 1, 2, 3. If we have Mihai always go first, then it will be something like 4, 2, 1, 3. Then at this point, Mihai, once he places 4, Bianca has none. Once he places 2, Bianca still has none. And then now we also ensured that the total number of even candies is greater than the odd candies. We now can say that, okay, this is a valid reordering. And then now if it's the other case where the even is less than or equal to odd, then we just print no. So in the end, this is just a greedy solution where we just have to check if the number of even candies is greater than the odd.